Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 3. It says organic compounds A, B, C, and D of comparable molecular mass are used to investigate the relationship between homologous series and vapor pressure. So to investigate what? The relationship between homologous series and vapor pressure at temperature 20 degrees Celsius. The results obtained are shown in the table below. Then 3.1 says define vapor pressure. So let's run quickly to that. We say the vapor pressure is the pressure exerted by the vapor at equilibrium with its liquid in a closed system. Then, 3.2 says give a reason why the temperature is specified. So we can see that we are given here that the temperature is 20 degrees Celsius. Now, why is it so? It's because that is the control variable. It has been kept constant in the investigation. So all these vapor pressures have been obtained at the temperature of 20 degrees Celsius. So it is that control variable. Then for this experiment, write down the dependent variable. Now the dependent variable is the one that we are, the physical property that we are investigating, right? So it's the vapor pressure. So had they asked for the independent variable, you'd say is the homologous series, because now they're investigating the effect of the homologous series in the vapor pressure, right? So, but our dependent is always one of the physical properties. So either the vapor pressure, melting point, or the boiling point. Then 3.3.2, the control variable. This is the variable that has been kept constant in this investigation. And then we've already stated that it is, that was the vapor pressure for 3.3.1. And then for 3.3.2, the ones that have been kept constant is the masses of the compounds and the temperature of the system, right? Almost got me confused there. Then 3.4 says arrange the compounds A, B, C, and D in order of increasing boiling point. So from the one with the lowest boiling point to the one with the highest boiling point. Now, easy to do that. We can see that this is just writing this from D all the way to A, right? So because we can see here it's increasing in vapor pressure, but then we know that since vapor pressure is inversely proportional to, so we already know the fact that our vapor pressure is inversely proportional to the boiling point. So obviously the ones with the higher vapor pressure have the lowest boiling point. So if we have to put them in order of increasing boiling points, they will start from here and then going up, right? So this one has a lower boiling point followed by that one. And this one here will have the highest boiling point according to the relationship. So that means my solution there, let's go check it, is just saying B, D, C, B, A, right? So writing it in terms of descending order in alphabetically. Then let's check the compounds A, B, C, and D in random order represent propan-1-all ethanoic acid butane, and 2-propanone. So now when they say in random order, that is to say, it's they're not saying that A is propan-1-all, they're not saying that B is ethanoic acid. So it's just in random order. So it can be anyhow. Then 3.5 says write down the vapor pressure of ethanoic acid. Now looking at all these compounds that we are given, we can see that ethanoic acid is the one with the strongest intermolecular forces. We know because of the two sides of hydrogen bonding. It has hydrogen bonds and two sides of hydrogen bonding. So it is the one that should have a lower vapor pressure because of its stronger intermolecular forces. Remember, if it has stronger intermolecular forces, then it has a higher boiling point, and a higher boiling point leads to a lower vapor pressure. So that means writing down our vapor pressure for ethanoic acid, that's 1.6 kilopascals, right? So that's the vapor pressure of the ethanoic acid. Now 3.6 3.6, they're saying fully explain the answer to question 3.5 by referring to intermolecular forces and vapor pressures. So now we want to explain why we say ethanoic acid is the one with the vapor pressure of 1.6 kilopascals. So how do we go about that one? We say the intermolecular forces in butane are London forces, whereas 2-propanone has dipole-dipole forces, right? And then both propan-1-ol and ethanoic acid have hydrogen bonds. That's a fact. But the hydrogen bonds, yes, are stronger than dipole-dipole forces and London forces. But then ethanoic acid has two sides of hydrogen bonds, whereas propan-1-ol has only one side of hydrogen bond. So if ethanoic acid has two sides of hydrogen bond, that means the hydrogen bonds in ethanoic acid are the strongest, resulting in ethanoic acid having a lower vapor pressure. So you will note the relationship that I also gave you, that intermolecular forces are inversely proportional to the vapor pressure. So the stronger the intermolecular forces, the lower the vapor pressure, and then the weaker the intermolecular forces, then the higher the vapor pressure. Right. Okay, so now let's proceed. We have 3.7 says, which compound represent 2-propanone? And then they say, explain how you arrived at the answer for 4 marks. So also again here, we must be able to explain that. So, okay, let's go about explaining that one. So which compound? Now, looking at this, observing this, remember we said that ethanoic acid has two sides of hydrogen bond, and then it fits to this vapor pressure. But then looking at what else, propan-1-ol is an alcohol, it has hydrogen bonds as well. So it is fitting that it will have this 2 kilopascals here as the vapor pressure. Then obviously the D part is the butane because it has the weakest intermolecular forces. So let's go ahead and explain that. We say compound A is ethanoic acid with two sides of hydrogen bond with a vapor pressure of 1.6 kilopascals, then followed by propan-1-ol with one side of hydrogen bond with a vapor pressure of 2 kilopascals. Then 2-propanone is dipole-dipole forces, whereas butane has London forces, right? Dipole-dipole forces are stronger than London forces, but weaker than the hydrogen bonds. Therefore, butane will have the highest vapor pressure of 204 kilopascals, since it is the one with the weakest intermolecular forces. That means higher vapor pressure. Thus, compound C represents 2-propanone, right? Because if we say the 1.6 kilopascals is for the ethanoic acid and the 2 for the alcohol, then this one is for the butane. Then it's obvious that compound C has to be 2-propanone. Right. So that's how we were just supposed to tackle this question, guys, for a total of 15 marks. So we said whatever mark that they give you there, do not give any mark to charity. Make sure that you know this topic and you just grab all the marks that you've been given here. This is the easier part when it comes to your organic molecules or organic chemistry. So make sure that you master this topic very well, not to lose any mark. So, okay, we've came to the end of the lesson, guys. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please press that subscribe button. And also, if you are seeing these videos on Facebook, please like and follow the page. And then also do not forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.